Hi guys! Finally received all the components for my another new build. It is super light frame from the TBS. Light motors as well from Mamba. I was waiting them 3 weeks, actually arrived from the US. They arrived with the all-in-one flight controller, 35 amps, because this one will be the 7-inch for the long range. We need TBS crossfire. We need of course GPS, waiting Cadex Vista. This drone will be based on the analog setup with the analog camera and some small canopy. I am aiming for this setup to be around 200 grams. Let's see how we're going. If you're interested, stay with us and we will put this drone together. Starting with frame. This is TBS frame, ultralight 7-inch. This frame built as a sandwich. In the middle you can see the material called Rohacell. It is so light material, but make this frame actually pretty strong. On the top and bottom side, here you can see the carbon pieces, which make this frame even more stronger. This frame 37-38 grams. Also we have canopy, which is made from the nylon material. It will be 52 grams and plus screws, it's going up to 54 grams. We're not going to use this canopy in our project. We're going for something lighter. We already print. Without screws it will be just 43 grams. We are going to use Mamba motors. This is 2204 motors 1450 kV. This motor is made for 5-inch prop drone. We will be fine with 7-inch props as we are building a light version of the drone, using light frame and lightweight components where it is possible. Also, a low kV motors has wings of thinner wire, so it will carry more volts at fewer amps, produce higher torque and swing a bigger props. 22 grams, which is pretty good. See how they're going. Just start put all motors together. I realize that those screw is actually stainless steel. Worries about every gram of our end product. We're going to check how we can find other screws. It is pretty easy. All those screws which was in the pack, magnet, and it's actually see they can magnet here. However, they put the aluminum one for the motors. It is pretty good. We're going to use them. And all the screws for the motors. Need to find better screws. I'm going to check all my packs. Already spent 10 minutes and I didn't go so far. You see how many screws here left and I didn't find much. And I decided to optimize this process with the magnet. Just go like this. Put all the screws here and everything what will be left here will be aluminum one. I just screw all motors to the frame. And let's see what weight will be now. We are getting 130 grams frame with motors. Pretty good, pretty good. Next, let's talk about flight controller. We have Mamba flight controller, which is based on the F7. Also include barometer. Here they say it is weight just 7.5 grams, which is so light. What we can see inside is instruction. As I mentioned before, we have ability to connect digital system here as well. Analog camera, which we're going to do test with the analog camera first. And when my Nebula Nano come, we will swap it. We can put LED, but we're not going. This is extra weight. We can connect here GPS with compass as well. However, we're going to use just GPS. It is cheapest one, BN220. Maybe in the future I will swap it. and to use all the functionality. It is good to have compass as well. Here we have built-in barometer. Yep. Let's see what else inside of the box. We have flight controller. Pretty good quality, so light. Also we can see capacitor inside, 470 for 35 volts. Cables to connect digital system and other cables. XT60, but I think we're going to use XT30. It will be more than enough. Power cables as well. And pretty much that's it. Let's see how it will fit on our frame. Okay guys, just spent few hours and finally I put all parts together on this drone. You see that here the big props. Props we are using here Mamba 2204, which is 1450 kV. I have to redo this TPU print to match flight controller. Let's connect flight controller to the computer. Let's install iNav and configure it. Before flashing new iNav firmware, let's check what is on our flight controller currently running. Connecting the flight controller, we can check that we are running Mamba F722. Also double check it through the CLI by typing version command, just in case that we are not flashing incorrect source to the board on the iNav, because installing incorrect firmware potentially could make a break for our flight controller. We have to be careful. Now connect our flight controller to the iNav, choose firmware flasher, choose our flight controller Mamba 722. Check the release notes. Press flash the firmware. It takes few minutes. Firmware will be flashed to your flight controller. Do not disconnect it during this process. Flight controller will be automatically reconnected. You will be asking what default values you have to use. Just choose here mini quad with 37-inch props. It will apply some default settings. Calibration we will do later. Let's configure ESC outputs. Choose D-Shot 600. Our flight control actually supports 300 or 600. Now you can check if the flight control positioning correctly. Face it forwards. Let's activate motors output with the D-Shot 600 like we already done before. Checking the motor direction. Yes, you have to do it without the props. However, I will push this quad down when I'm checking. Don't do this actually. Always pull out props. All motors looks like in the right direction. If not, you have to use BH Heli to revert spinning of the motors. Next, go to the presence and apply generic 7-inch quadrocopter filters and optimization settings. On the configuration settings, we are not choosing magnetometer as we do not have one. Again, I already ordered brand new and wait till I can install it. Next settings, you can see positions of the flight controller and GPS settings. We have to enable GPS. We are choosing a U-Block 7 for the all new GPS chips. Activating battery voltage monitoring and amps monitoring. And as on the flight controller documentation, Current meter scale must be 120 to provide correct data. Rest of the settings I'm leaving as is, and we're going to save the config now. Next, we set up ports. Receiver on the UART2, UART1 we're disabling. On the UART4 we don't need any MSP, GPS actually on the UART4. UART3 we set up with the TBS Smart Audio, and UART6 is not in use. I just realized we do not have any GPS data coming in. Let's fix it. As you see, I just forgot to enable GPS. Let's enable it. And now you see GPS is in. We are not touching any fail-safe settings for now. PID settings we will leave as is as well. In the advanced settings, I'm just going to activate use mid-throttle for alt hold. It helps us to test batteries without compass on the hovering mode. Let's set up receiver now. We are using serial type of the receiver, and it is Crossfire. Checking now if the radio works correctly. Quickly setting radio modes. Setting OSD is always personal preferences. You can set up whatever you like. I just tried to leave the drone and it started spinning in the circle. Quick troubleshooting, I realized that we didn't let INAV know or flight controller know that we have probes spinning out of the camera. Looks like our drone is ready. Let's go outside and test it. Okay guys, let's test how long this new build will be on the air. Sorry for repetitive sound during the test. It is vibration from my radio. It's set up for the 4S battery alarming. Forgot to turn my goggles on for recording, and my friend actually helping me in the background at this moment. Could you please start recording the video? On the goggles, yeah? Oh. I forgot completely. Okay guys, we achieved our goal 10 minutes here. Battery now 3.6 as you see, we can fly even longer. Of course the hovering mode will not give you the real test of the flying for the long range mountains or whatever. 3.6 volt here. Jared with me. He is one of the best Melbourne freestyles, and I will put his link down below as well. Thank you very much, Jared, for your help today. Yeah, 3.6 volts. I'm not sure we have to go deeper, and so already 11 minutes flying. The battery actually not flashing yet. Like you know, they're flashing, you have to land. It's not flashing yet. And yeah, now 11 minutes and we have 358 per cell. I don't like to kill these batteries. Yeah, but we can fly a bit more. After this test I will do a bit freestyling for you. Not actual freestyling, but we will go a bit aggressive with the drone. Again, weight of this drone when I start flying was 249 grams. Fully equipped, of course without digital system on board. Total flying time 12.5 minutes. Now battery flashing and I go into land. And 3, 2, 1, 12.5. Fantastic. Don't forget to like, subscribe and comment this video.